My name is Gabor. I work for Ataccama as well. Today I'm going to talk about the Oncall Copilot we developed for our team within the company to help with our own calls during incidents, smoothing the investigation. So a little bit about the agenda. Yeah, we will start describing the most stressful situation when you get wake up at 3 a.m. in the night, and you need to resolve the incident. So, like we said, let's leverage AI because they say that AI or LLMs are pretty good at summarizing stuff and understanding context. So we try to use its features for the simplifying the life of an on-call engineer. And then we're just gonna go through some of the commercially available landscape, comparing different solutions. And then I'm going to show you the architecture of our custom-made solution that we are using in the company, how it's being deployed, and of course, I want to show you some stories from the battleground where we use the agent or the Oncall Copilot and where it was helpful for us. Of course, I'd like to call this out. It's not ideal, it's not perfect, it's an LLM, so it's non-deterministic. So you still need the human in the loop to make good decisions. And I'm gonna talk about our future plans as well. So yeah, as I can imagine, most of you already experienced this situation. You are in a new team, you start your on-call duty, you don't know anything about the service, and now you receive the page at 3 a.m. in the night. You need to dig yourself through the wikis, reverse engineer the code. Now you are attempting to reverse the code and pray that if it's really fixing the issue. You spend a lot of time in the observability stack. You check the logs, the metrics, the traces from Grafana. You check your rollout pipeline. So, a couple of months ago, we had this idea, can we somehow leverage AI to solve at least some of these problems or make the journey a little bit smoother? So, and then, of course, you have different engineering personas. So what I described as a junior, I mean junior in the sense that it's a junior in the team, doesn't know too much about the context or the code base. So for those, we wanted to lower the barrier, so simplify or make the understanding of the code base easier, help them to navigate within the observability stack, how to connect the signals, how to connect the dots. But we wanted to develop something that's even good or useful for more senior people who already know how to find the root cause, but they don't want to spend hours in clicking between multiple tools, correlating the signals. On one hand, we want something that teaches these new folks, but on the other hand, it can even accelerate the workflow of those senior people. What I would like to emphasize, this is not an agent, and I made this choice deliberately. This is a copilot, because at the moment with these LLMs and the non-determinism, we don't really want to have a solution that pushes a code and automatically merges something or resolves a ticket, because you still need someone who validates if the theory behind the root cause analysis or the incident analysis is correct or not. Yeah. And back then, when we came up with this idea, we didn't know too much about what's available out there. And of course, we just wanted to create a proof of concept. So of course, buy versus build is a valid thing, but back then we didn't want to bloat our cloud builds with a new service where the added value is questionable. That's why we said to ourselves, we have an AI team within a company, let's leverage our knowledge and let's try to apply that knowledge into our own solution. And if it's feasible in the future, we can replace it with a publicly available solution. But just to give you a glimpse of what's being out there or what's available on the market. So like some of the platform giants are already coming up with some solutions. So if you are like on Datadog, you can use Datadog Beats AI. PagerDuty Advanced is somewhat better than pure PagerDuty, but it's not solving the whole complexity what we try to solve with our use case, let's say. And there are some really interesting emerging technologies. For example, I really like the solution from Incident Fox, and I try to compare like feature by feature with our solution, and it looks pretty similar and it's pluggable. So if we really find out that the solution is feasible, we would like to reevaluate if we should reach out for one of those publicly available solutions, because we obviously don't want to reinvent the wheel. Yeah. So now speaking about like how we design the system or like how we thought about like investigating an incident or finding the root cause. So what I'm describing right now is the happy path. So you somehow trigger the ingestion. Hey, I have an alert. Here's the PagerDuty alert. Can you tell me what happened here? And behind the scenes, this LLM-based system, the Copilot, has knowledge about the service mapping within our company. It has some tools to retrieve the code base, retrieve the runbooks. It has access to our like GitLab or GitHub, and has access to all of our like observability stack, Sentry, Grafana, metrics, logs, traces. What's even more important, we're living in a distributed system, yeah. So like everybody is doing distributed systems with multiple microservices. It can happen that your service is failing because the dependency is down. So with leveraging like open telemetry traces and like cross correlation between the logs and traces, we try to identify the root cause even like outside of our service, because essentially that's the goal for the company or for the on-call. You can't really just think about your team, but you need to think about the cross-team impact as well. And finally, there is some report. So it contains some summary about the findings and some theories and links to the relevant signals. I'll speak about it a little bit more in details later. But like one thing again, I don't want to talk against the LLMs, but we need to understand that like a copilot or an agent or an LLM-based solution is a force multiplier, but it's not a miracle. So it's not resolving the problems for you. You need to think about it as a helpful colleague that can help you to understand the context better or dive deeper in a faster manner, but it's definitely not something that will somehow magically resolve all your problems. And like one more important aspect is if you have a bad observability, an LLM won't solve that for you. So you still need to have good dashboards, good documentation, good runbooks. Yeah, and now I already described the thought process, how we are like trying to investigate an incident. And now let's talk about the tools we expose to this Copilot. So this is more specific to the stack we are using in the company. I can imagine that like other teams or other companies would use like a different set of tools, but we use like different MCPs from different technologies on the stuff we use at the company. So we have like Grafana with logs, metrics, and traces. So we expose all the accessibility to querying, Loki, Tempo, PromQL, and for like front end we have Sentry, and essentially we have like a correlation between front end and back end, so you can trace the requests end to end between the front end and the back end. Yeah, and now let's say the brain part is the integration with PagerDuty, because that's in our case the main entry point for the incidents. GitLab, and like some teams have not just the code base but the documentation, the other definitions, and the signal, or like the emission of the metrics traces within their code base. Some other teams have that knowledge, like the runbooks in Notions. That's why we expose even the knowledge hub, let's say, to the Copilot. And of course, we are Kubernetes based. Sometimes you have issues directly in Kubernetes, so we exposed the Kubernetes MCP and the Argo CD for like troubleshooting, let's say, on the low level. And obviously, we have some custom MCPs as well, because every company is different. You have different topologies, you have different setups. There's like company-specific knowledge, and there are some like utility tools that's like, I don't know, like a good example is like a Grafana link shortening. The Grafana MCP at the moment doesn't expose that, so we created our own tool. It's not really rocket science. We just found it useful, so we built an MCP server for that. Now, the first question I got when we came up with this idea, like, what is so special about this? Like, I see just a bunch of MCP tools exposed to a system. I can do that. And the answer is nothing. There's nothing really special about this. Like, anybody can do it. What's the real value in a case of a company or like a more complex architecture is the glue. Yeah. So we have, I don't know if you have seen the paper about like skills or sub-agents from Anthropic. So we have custom skills that describe topology of our company, how the dots are interconnected within our observability stack, what clusters are out there, how they are connected, how is the backbone done, etc. So this is really the nuance that makes the thinking of the Copilot better, because now it has tools to retrieve information that are specific to your team or your company or your service. And just to give you an example, when we ran experiments, like when you just expose the MCP tools, it was somewhat helpful, but most of the times it didn't find the root cause, or you burned like a huge amount of tokens unnecessarily, because every time you executed a query, it wanted to go through all the different stacks, and it was like brute forcing. Yeah. Now, if you have this, it's getting better. But let's make a note again about the non-determinism. When we're talking about LLMs, you can't really say that, oh yeah, I forced my agent to do this and that. It's not true. The probability gets higher, but you can't really enforce anything. Yeah. So that's like another important thing I always point out. Yeah, and at the end of it, we have like let's say the report about the incident. On the screenshot, I'm just like sharing some incident report I generated some weeks ago, and the reporting can be adjustable. Yeah. As I said earlier, for a junior or like a beginner in the team, it's better if they can get direct links to the dashboards. And that's even useful for a senior because, for example, myself, I'm not fully trusting what the LLM outputs. Yeah. For me, it's good to have that link to the dashboard or have the link to the queries. So I can really validate if the output was correct or not. And like another great thing is, this is like the report is not final. This is an interactive system. You can still use it as a chatbot. So even if you find some relevant signal, you can still continue the discussion. You can dive deeper. You can ask questions about, hey, but how this part of the code is working, or why am I getting this 401 all the time? Yeah. So that's like a different to things I have seen before the big LLM boom, that you can still continue. And if it has access to the code base, it can find things faster than by normal, regular human searching. Yeah. Yeah, let's speak about a little bit about the deployment model. So in the first iteration, we didn't really want to fully reinvent the wheel. There are like commercial tools out there. They have already an agent harness. So we wanted to leverage that. So we have Cloud Code, Cursor, root code, in VS Code, and you can name like 20 other tools. Doesn't really matter. What really matters is that right now we have like a central community maintained repository of all the company-wide knowledge and the skills you can put into the agent and the prompts. Sorry, the copilot. Yeah. and like what's good about this? Like we are running this right now in a pilot phase, let's say. So there's like a continuous improvement loop involved. A lot of teams or some early adopters are using this tool for their own calls. We collect feedback from their incident evaluation, and like once we see a red signal, we try to feed it back into the system to adjust the prompts, adjust the skills, and literally find out how to improve it and make sure that the next time the same thing happens, it finds the right root cause. Yeah. Yeah.
Maybe we will have this on another slide, but you mentioned that the community is improving your skills. So
yeah.
You share memory bank and you use like, community in the company to improve. How do you evaluate the benefits of the changes?
Yeah. Yeah. I think yeah, so the question was about like how are we evaluating the quality of the changes when somebody changes a skill or a prompt. So there are like different techniques, and there's going to be a slide about this later. But like you have different evaluation systems. The best thing you can do is like do a training set, let's say, where you know the exact root cause already. You know like what would be the thought process to resolve it. And now you are validating these checkpoints if it was really like going through the same thought process and if the output is somewhat correct. And like you need to, it's basically something like a testing framework, but it's slightly different for an LLM-based system. And you need to run this like continuously. Yeah, so like it's a sort of a quality gate. So when you change the skill or when you change the prompts, you need to run these tests to see if there's a drift or not. Yeah. Yeah, and then like later on, we experimented with building our own agent for this with a proprietary agent harness, and like the main reason was that we wanted to, or there's still a plan for this, but we need to evaluate how much better this is compared to the publicly available solutions. To own basically the whole thing end to end, yeah, because like you control with that, you control your own destiny, and you can still expose it as a plugin into Cursor or Cloud Code, and the teams can use it for their investigations. So yeah, and this is like a little bit about that training, yeah, like how we did like in the initial phase, how we trained basically those skills and how we found out what's like a good skill. So we basically applied some chaos engineering practices or game day testing. Yeah, we wrote down a bunch of dependencies of the service, or we injected some faulty configurations into the Helm charts. So we knew that there's going to be an incident, and we knew the root cause. So we basically edited the skills and the prompts until it found the right root cause, let's say, and did the right investigation process. like this is the manual version of what I described earlier, but it was good enough for the first iteration. And again, what I would like to call out, because I see this nowadays as a pattern, like people tend to use LLMs even for this, like you create an artificial incident, you know the root cause, and now you just like iterate with the LLM to modify the prompts until it finds the right root cause. In my experience, that's not really the right approach, because at some point you lose the understanding of what the skill of the prompt is doing, and it can like completely diverge from your desired state. So be really careful about, like at least at some point there has to be a human intervention. Maybe this is going to change in the future. I'm just like talking about my experience at the moment. I don't know how these LLMs will evolve in 5 years. Yeah, and like this is the current like continuous evolution or continuous evaluation and improvements we do. So we have this like early adopters who are collecting feedback from their incident investigations, and then we basically reiterate on the prompts and the skills, and we try to like improve the quality of the output. And like we would like to automate this in the future, because we need like an automated gateway that tells you if there's a regression. Now, some stories from the battlefield or like some real use cases. Obviously, I can't really share everything because it's still like, let's say, our like secret. Yeah. So, this was like some weeks ago. I received an error about the error rate on a REST API service where the rate for the 500 was breached. And like, I tried out the Copilot. It pointed out that the credentials were like not appearing for new tenants, and they were missing from the service discovery. So it created like 3 different theories, and one of them was like, why is it not showing up in service discovery? It should be there based on the the code base and the context itself. So yeah, like we validated the theory with the owner of the service discovery solution. Basically, they found out that during the migration they did on the cakeload resources, they forgot to like onboard basically new things. So it was like a company-wide impact, but we found it on time, so it was reverted back on time. Again, I'm pretty sure that like I would be able to find it because the signals were there. But in this case, I didn't have to go like manually to any of the dashboards or found some signals in Grafana or Sentry, or going through like kubectl. It just like gave me all the outputs, and I could like show that report to that other team. So that was like a game changer in my case. I can imagine that for a complete newbie in the team, it has like even more value. But like even for myself, it was pretty impressive that I didn't have to click around, and it found the root cause. Yeah. Sorry. One more thing. And but like I still see there's some room for improvement, because all these like migration activities were announced. It was announced somewhere in Jira or on Slack. So if we had that integration, maybe it could pull in even the context, so I don't have to like connect the dots manually. But we are not there yet. It was still useful, I would say. Yeah, like a second incident is related to Postgres migration. Again, the same alert fired on the same service, but in this case, the symptoms were different because that's just like a safety net alert. So the connections to the DB started to fail, and basically the agent or the Copilot gave me the insight that something is broken with the EGHBA rules, or there might be some non-SSL connections. And again, this was like a behavioral change in the newer version of Postgres, chatted with it further, like, hey, can you point me out the differences between the two versions? And I spotted that. So we had to change the configuration of our Postgres connections, but it was still like, saved me a lot of time, and I didn't have to like go manually and browse on the internet for the change notes. Yeah. And the last one is about the the RabbitMQ networking issue. So we have like a managed RabbitMQ that's owned by a different team, and we don't have like too much insight. So the only signal we got is that the processing is taking too long, the processing of the messages. And like in this case, it was pretty simple. It just told me that we should go into the maintainers of that like RabbitMQ stack and check with them what happened. Like, okay, this is not really like a really great example. What is great about it, that it didn't start to like hallucinate theories about what went wrong. It directed me to, hey, you should ask you should ask for more insights instead of, I think this is what happened. Yeah. Okay. I think I already said this, but like, let's elaborate on it a little bit more. Doesn't matter if you have the best agent or best LLM-based solution in the world, if you have like poor quality dashboards, poor quality telemetry. So you still need to invest into this. You still need to have good documentation. And again, like, don't expect that the AI vibe coding will like get you out of this. You still need to do the investments into proper alerts, proper metrics. And the same goes for on-call. Like, I see that this tool can be useful or is already useful, but you still need to be able to connect the dots. You still need to learn the stack. You still need to understand how the services connect. You can't really expect that like all the problems will be solved by this tool for you. Yeah, and again, like as you see on the picture, like you inputted the same thing to the LLM, it outputted 3 different things. So yeah, this is a non-deterministic system, and yes, context engineering and the skills can improve your output, but you simply can't say that it will be ensured. It won't be ensured. Yeah, like you input the same thing 3 times, you will get a different thing on the output side. So there has to be, at least at the moment, some human in the loop that validates those theories, and someone who really understands what really happened and can tell you if the LLM is misleading or not. Yeah, and just some things about our future plans. So what we want to achieve, doesn't matter if it is like proprietary solution or the publicly available ones, we want to somehow correlate the incidents. We want to find out what was the actual causing incident, because in these like distributed systems, you would have multi-system impact. Yeah, and that's the problem usually. How do you deduplicate into a single event? When do you find out which one was the actual root cause? Yeah, and we would like to run some experiments with multi-agentic systems, although I don't necessarily see an added value, but still, like, maybe it can speed up some of the investigation. And for the automated response, like, I saw already some systems where when you receive an incident, like what you usually do, you go to Grafana, you go to Sentry, and you collect the dashboards, you add it to some ticket or to PagerDuty. So this cumbersome part can be already like auto-ingested. So once you wake up and you get to your computer, it's already filled out at least with some minimum set of information you can start to use for your investigation. Yeah, and And of course, like related to this, we would like to see the cross dependency impact. So improve the way how it understands our topology, or how it like generically speaking understands the topology of a given solution. Yeah. So that's all from my side.